Yes, in this class we will discuss another concept in statistics called regression. In the last class I have told about correlation and correlation coefficient R. So here this regression it represents the estimation of one independent variable in terms of other. So it estimates one independent variable, for example maybe x, in terms of another variable which is y. So suppose if I take x as an independent variable and y depends on x is independent variable, y is dependent variable, it depends on x. So that means y is equal to some function of x. So if I take this f of x as ax plus b, so y is equal to ax plus b, you can see that this is a linear equation. So if this y is equal to ax plus b represents best fit line, how to fit best fit line we have done using method of least squares. So then we say that here y is equal to ax plus b, this is a regression line of y on x. So y is equal to ax plus b, this becomes a regression line of y on x. So that means by knowing the values of x you can find out the values of y. Suppose if you interchange means, suppose if y is the independent variable and x is the dependent variable, so what happens in this case, the equation will be x is equal to ay plus b. X is equal to ay plus b, this is the best fit line. Then this line is called as the regression line of x on the floor. So that means in a given problem, some set of values of x and y will be given. So x and y values are given. We have to fit a regression line. So if you want a regression line of y on x, that means it is y is equal to ax plus b. Suppose if you want to fit a regression line of y on x, so we have to use this equation. The equation is y is equal to, capital Y is equal to, see here, sigma xy divided by sigma x square into sigma x into x, not sigma x. See, this is the regression line of y on x. Here, this capital Y is small y minus y mod. I have used this capital X and Y in the earlier video also when I explained about correlation. Similarly, capital X is x minus x mod, where x bar and y bar, they are the mean of x and mean of y values of the given set of data. So we have to find out capital X and capital Y, then we have to take their product and we have to sum them up. That is your sigma xy. And we have to square this capital X value and then add, that is your sigma x. So by using this equation, you can get the regression line of y on x. Similarly, if you want a regression line of x on y, that means x is equal to a into y plus b. So this is the equation. Then x and y, capital X and y are interchanged here. that means x is equal to sigma xy remains same divided by, instead of sigma x square it is sigma y square into, instead of x it is y. So it means the same here. So this is the regression line of x on y. This is the regression line of y on x. So for a given set of data x and y, we can fit the regression, two regression lines like this. Of course, naturally they are the best fit lines. So using this concept, now we can do a problem of fitting the regression lines for a given set of data. Let me take the problem like this. The problem is obtain the lines of regression. So I am going to take the problem. So it is like this: obtain the lines of regression and also the coefficient of correlation. So both. So obtain regression lines, equations, and correlation coefficient, that is R value, correlation coefficient for the data given. For the data given. Now here, let me take the data like this. X and Y data are given, x and y. So for a given value of x, corresponding values of y are given. 1, 2, 3, 4, 5, they are the x values. Y values, corresponding y values are 2, 5, 3, 8, 7. Okay, corresponding y values. Now let us find out the regression lines, two regression lines, and also the correlation coefficient R. Yeah. Now first thing we have to find out the average values, x bar and y bar. So x bar is nothing but summation x divided by n, number of data sets. Summation x, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Divided by number of data sets is 5. So 3. 3 is x bar, then y bar is sigma y by n, 7, 10, 18, 25. 25 divided by 5, it is 5. Okay. So these are x bar and y bar. Once you get that, capital X will be x minus x bar, that is x minus 3. Capital Y is y minus y bar, that is y minus 5. Now we will have another, the values of xy and x square and also y square. So we need these three things: xy, sigma xy we need, sigma x square we need, sigma y square we need. So for that we need to have the values of x and y. So we will calculate this in the form of a table, as we did in the last problem. Then we will put the equation. So we will have the table now. So in that table we need x value, capital Y value, then x into y, then x square, then y square. Totally 5 parameters we require. So let us calculate these 5 parameters. The capital X is small x minus 3. Capital Y is small y minus 5. Yes. So there are 5 sets of data here. So let us calculate now capital X values. X minus 3. So x is 1 here. So 1 minus 3, which is minus 2. 2 minus 3, minus 1. 3 minus 3, 0, 4 minus 3, 1, 5 minus 3, 2. Then capital Y values, y minus 5, that is 2 minus 5, minus 3, 5 minus 5, 0, 3 minus 5, minus 2, 8 minus 5, 3, 7 minus 5. Next we have to take the products of these two, x and y. So x into y, minus 2 into minus 3 is plus 6, minus 1 into 0 is 0, 0 into minus 2 is 0, 1 into 3 is 3, 2 into 2 is 4. Then we have to square this, that is x square, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 2. Then we have to square the second, that is y. You will get y square, minus 3 square is 9, 0, 4, 9. Now we need to have these three things. We have to sum them. Sigma xy I need. Sum of all these 6 plus 3 plus 4, 9, 13. Then sigma x square. Sum of this 5, 6, 10. Then sigma y square 9 plus 4 13 22 26. So these are the values now. Now once you get this these three sums here, now you can write the regression line equations. So I can use this regression line of y on x. So that is in the form y is equal to ax plus b, in this form. So capital Y is equal to sigma xy divided by sigma x square into x. So this is the regression line. Now here you can write this y as y minus 5. Small y minus 5 is equal to sigma xy is 13 divided by sigma x square is 10 into x is nothing but x minus 3. So this is the equation. So you can just cross multiply and write in the form y is equal to ax plus b. So 10y minus 50 cross multiplication is equal to 13x minus 39. Or I can write this as 13x minus 10y minus 39 plus 50, that is plus 11, is equal to 0. So this is the equation. Or in other words, you can write this as y is equal to mx plus c, that is ax plus b form also. So that means if I want in that form, so this is the equation. If I want in that form, y is equal to this 5 you bring to that side. So 13 by 10x minus 39 by 10, which is 3.9. If you bring to this side, plus 5. So finally it is 1.3x plus 11. 1.3x plus, not 11, plus 1.1. Plus 1.3x plus 1.1. So that is the regression line of y on x. So if you want regression line of x on y, line of y, x on y, it is x is equal to ax plus ay plus b. So here you have to interchange this capital X and capital Y. Capital X is equal to summation xy by summation y square into y. That means x is here x minus 3. So x minus 3 is equal to sigma xy is 13 divided by sigma y square is 26 into y minus 5. Capital Y is small y minus 5. So you can simplify this also. So here, if you want in this form, x is equal to plus this bring to this side we have plus 3. So it is 13 by 26 means 0.5. 0.5 times y minus 0.5 times 5, that is 2.5 plus 3. So it is finally 0.5y plus 0.5. So x is equal to 0.5y plus 5 plus 0.5. So that is the equation. Otherwise, you can cross multiply this and you can get in another form. 26x minus 26 into 3 is 78 is equal to 13y minus 65. Okay, the cross multiplication. So this will be 26x minus 13y. And if you bring to this side is plus 65. So minus 13 is equal to 0. Or we can divide both by 13. So 2x minus y minus 1 is equal to 0. So this is the other equation. So these two are the regression equations of y on x as well as x on y. Now we have asked the correlation coefficient also. Correlation coefficient we can use the formula which we have used earlier. So R is equal to sigma xy by root of sigma x square into root of sigma y square. So correlation coefficient R is equal to sigma xy divided by square root of sigma x square into square root of sigma y square. So this is the formula to find correlation coefficient R. So sigma xy is 13 divided by root of sigma x square is 10, so root 10 into root of sigma y square, that is 26. So this is the answer. So if you simplify that, you will get 13 divided by square root of 10 divided by square root of 26, 0.8062. So this is a positive correlation, positive value got R. That means as the value of x is increasing, value of y also, of course, it increases here, then only one value reduces, then it increases. Okay, so that is why the value is of course greater than 0.7. So it is a good correlation. You can say that it is good correlation. So there is a good correlation between the set of values of x and y, and these are the correlation regression lines. So regression, it gives an idea about how one variable depends on the other variable. So just by giving the values of x here, we can find out the corresponding values of y using these regression lines. For example, I will take an example. If x is equal to, if you want to have the value of y, or x is equal to 6, because I am extrapolating. Suppose if x is equal to 6, what is the corresponding value of y? So y can be obtained using this. So y is equal to 1.3x plus 11. 1. So that is 1.3 into 6 plus 1.1, which is 7.8 plus 1.1. You can take it as 8.9. So approximately it is 8.9. So when x is 6, so the value of y is 8.9. Similarly, if you want to find the value of y, x for given value of y, for example, if y is equal to, I will take some value, y is equal to 10, which is not there in this, what is the corresponding value of x? So for that you can use this equation, x is 0.5 into 10 plus 0.5. 10 plus 0.5, which is 5 plus 0.5, 5.5. So when y is 10, x is 5.5. So like this, we can find out for a given value of x, what is the value of y, and for a given value of y, what is the value of x, by using these regression lines.